Have you ever looked up at the night sky and wondered, what was there before all of this? Before the stars, before the galaxies, before the universe as we know it even began. We all know the story of the Big Bang, a single, super hot, super dense point that exploded 13.8 billion years ago, creating everything. But the billion-dollar question remains, what happened before the Big Bang? Was there just nothing? Or was there something else entirely? Today, we're diving headfirst into the mind-bending world of theoretical physics to explore the most fascinating ideas about what came before our universe. So buckle up, because things are about to get weird. Let's start with a popular and somewhat poetic idea, the cyclic universe, also known as the Big Bounce. Imagine our universe is like a cosmic accordion. It expands from a Big Bang, reaches a maximum size, and then, pulled back by gravity, it collapses in on itself in a big crunch. This collapse heats everything up, compresses all matter and energy back into an incredibly tiny point, and then, boom, a new Big Bang occurs, starting the cycle all over again. Our universe would be just one in an infinite series of universes, born from the ashes of the one before it. In this model, there's no true beginning. Time stretches infinitely into the past and future, filled with endless cycles of cosmic birth, death, and rebirth. It's a beautiful thought, isn't it, that our end could be a new beginning, but modern observations show our universe's expansion is actually accelerating, not slowing down, which poses a big challenge for the simple Big Crunch idea. However, newer versions of the theory suggest other mechanisms could trigger the bounce, keeping this cosmic cycle alive. Now, let's get even bigger. What if our universe isn't the only one? Welcome to the multiverse. This isn't just one theory, but a whole collection of ideas suggesting that our universe is just one bubble in a vast, cosmic ocean of other universes. One popular version is called eternal inflation. Imagine the moments right after the Big Bang, when the universe was expanding at an unbelievable rate. According to this theory, that expansion, or inflation, never truly stopped. It might have stopped in our little pocket, allowing our universe to form, but it continues raging on in the vast space between universes. Out of this chaotic, eternally inflating metaverse, new bubble universes are constantly popping into existence, each potentially with its own unique laws of physics. In one universe, gravity might be stronger. In another, there might be different fundamental particles. Some might be sterile and empty, while others could be teeming with forms of life we can't even imagine. It's a staggering thought. Billions of universes, each a separate world, existing alongside our own, completely inaccessible to us. So, what was before our Big Bang? In this view, it was simply the moment our bubble universe branched off from this greater cosmic foam. To explore our next idea, we have to go smaller, much smaller, to the realm of string theory. String theory proposes that the fundamental building blocks of reality aren't point-like particles, but tiny, vibrating, one-dimensional strings of energy. What does this have to do with the time before the Big Bang? Well, a branch of string theory called brane cosmology offers a dramatic origin story. Imagine our entire three-dimensional universe is just a membrane, or a brane, floating in a higher dimensional space, like a sheet of paper in a room. According to this theory, there could be other branes floating in this higher dimension. The Big Bang, in this scenario, wasn't the beginning of everything, but rather the result of a cataclysmic collision between two of these parallel universe branes. Picture two massive sheets smacking into each other. The colossal energy released from that impact would be powerful enough to spark a Big Bang and create an entire universe, our universe. In this model, the before was a quieter, higher dimensional existence where our brane and others drifted, waiting for their cosmic rendezvous. But what if the question itself is flawed? What if asking what came before the Big Bang is like asking what is north of the North Pole? This is the core of one of the most famous and mind-bending proposals from Stephen Hawking and James Hartle, known as the no-boundary proposal. Using the strange rules of quantum mechanics, they suggested that as you go back in time towards the Big Bang, the distinction between time and space blurs and eventually breaks down. Think of the Earth. As you travel south, you can cross the equator and keep going until you reach the South Pole. The South Pole is a point on the surface, but there's no south of the South Pole, it's the end of that direction. Hawking and Hartle proposed that time is similar. The Big Bang is like a south pole for time. It's the point where time itself began. There is no before because the concept of time as we know it didn't exist. The universe, according to this idea, didn't pop out of nothing, nor did it come from something. It just was. It's a self-contained system, with no beginning or edge in time, much like the surface of a sphere has no edge. This elegantly removes the need for a creator or a preceding cause, making the universe entirely self-sufficient. Another fascinating idea pulls us right back into the bizarre world of quantum mechanics, the universe from nothing. But this nothing isn't the empty void you might imagine. In quantum physics, a perfect vacuum is not empty at all. It's a bubbling, frothing sea of virtual particles that pop in and out of existence for fleeting moments. It's a state of minimum possible energy, but that energy isn't zero. Theorists like Lawrence Krauss have proposed that our entire universe could have emerged from such a quantum vacuum through random fluctuation. It's called a quantum fluctuation essentially. The laws of quantum mechanics could allow for a universe with a total energy of zero to spontaneously appear from this nothingness. You might ask, how can the universe have zero energy when it's filled with so much stuff? Well, the theory suggests that the positive energy of matter and radiation is perfectly balanced by the negative energy of gravity. It all adds up to a neat zero, so our grand, complex cosmos could be the ultimate free lunch, a spontaneous creation allowed by the fundamental laws of physics. In this scenario, before the Big Bang, there was a state of quantum potential, not a true nothing, but a potential for something to exist. So, where does that leave us? A universe in an endless cycle of bounces. One bubble in a cosmic multiverse, the result of a cosmic crash between dimensions. A self-contained object with no beginning. Or a statistical fluke from a quantum void. The honest answer is, we don't know for sure. These ideas exist at the very edge of our understanding, where physics and philosophy meet. We can't run an experiment to see what happened before the Big Bang. Our physics, as it stands, breaks down at the singularity itself. But that doesn't stop us from asking the question. Each of these theories, from the big bounce to the no-boundary proposal, is a testament to human curiosity. They push the boundaries of what we think is possible and force us to confront the deepest mysteries of existence. Perhaps one day, with new discoveries from telescopes like the James Webb or breakthroughs in theoretical physics, we'll get a clearer picture. We might find evidence for gravitational waves from a previous cosmic cycle, or hints of other universes in the cosmic microwave background radiation. Or we may discover that the question itself is unanswerable. But the quest to understand our origins is what drives science forward. It's a journey into the unknown, a story that began 13.8 billion years ago, and one that we are still trying to piece together, one brilliant idea at a time. What do you think happened? Let me know your favorite theory in the comments below. Thanks for joining me on this cosmic journey today. If you enjoyed this deep dive into the mysteries of the universe, don't forget to hit that like button and subscribe for more mind-bending science. See you next time.